In this video, we're going to take a look at some of the problems from 3.2. 3.2 doesn't really introduce any new information except for the vertical line test, which we used in 3.1. So you can check that video if you need that. So what we're going to do in 3.2 is take some of the concepts that we've just talked about and some things that you may have seen before and put them together and look at some graphs of functions. So we're going to look at this example from the book. This is out of the exercises at the end of section 3.2. And we're going to work through this together. So we're going to use this graph, and we're going to remember that y equals f of x. That's key to all of this. Y is equal to f of x. If y describes a function, these are interchangeable. So as you go through these questions, a lot of times you're going to ask, are they giving me the y? That's here. Or are they giving me the x? That's here. And if they're asking for function values, that's the same as asking for y values. So let's start with A. We've got f of 0. This is f of x. And f of x. So f of 0, they're saying when x is 0, what is our function value or our y value? So you should be able to go to the graph and find where x is equal to 0. That's right here. And our y value is also 0. They've given us points for everything on the graph, but you should also be able to read it off of the graph itself. So when x is 0, y is 0. And we write f of 0 equals 0. So that's equivalent to the point 0, 0, but they're asking for it in this notation. Next, we're going to do f of 6. So x is 6, so we come up to the picture and we find where x is equal to 6. That's right here. When x is 6, y is, again, 0. So f of 6 is equal to 0. Okay, part B is very similar. F of 2 and f of negative 2. Again, they're giving us f of x. F of x, they're saying when x is 2 and when x is negative 2. So we should be able to read this off the graph. Put them in the right order here. Okay, so when x is 2, the graph is right here. When x is 2, y is negative 2. So f of 2 is equal to negative 2. And when x is negative 2, come here. Our point is right here. When x is negative 2, y is positive 1. Okay, so for these, they're giving us the x value, and we are finding the y value. All right, now the next one, it's a similar idea. They're giving us f of x. This time we can't read the exact values off of the graphs. They're asking us if it's positive or negative. So you can use the same idea that we did up here. You can find the x value, decide if the y value would be positive or negative. Even if you can't decide the exact value, you should be able to figure that out. Or we can look at this slightly different. And this is a way that we're going to look at graphs quite a bit in this class. So let's get familiar with it now, and then it'll be easier later. So one way that we can look at graphs is above the x-axis and below the x-axis. If we are looking above the x-axis, that means that all of our y values are positive. So these two things are synonymous. If y is greater than 0, we're above the x-axis. If we're above the x-axis, then y is greater than 0, or f of x is greater than 0. Okay, all three of those mean the same thing. And we know that at the x-axis, we have y is equal to 0, or f of x is equal to 0. We talked about that a couple sections ago. Okay, so that's the same as saying x-intercepts. All of those are the same. And then below the x-axis, we're going to have all of our negative y values, or negative function values. Okay, so above the x-axis, y and f are positive. On the x-axis, it's 0. Below the x-axis, we're looking for y is less than 0, f of x is less than 0, or in other words, negative. So for this one, it says, is f of 3 positive or negative? So this is the same as saying when x is 3, is the graph above or below? So that's another way to look at this problem. You could do it the same as we did above, or you can look at it this way. So let's go to where x is equal to 3, that's right here, and we see that the graph is below. Okay, so it's below, so it's negative. Or you could just estimate when x is 3, y is, maybe negative 1.5, something like that, but it's definitely negative. So the answer for this one is negative. So negative function value goes with below the x-axis. And then here, when x is negative 1, is the graph above or below? So we go where x is negative 1, and we see that the graph is above. Okay, we don't know the exact value, but we can tell it's definitely above. It's definitely a positive y value, positive function value. So this one is positive. All right, moving along to part E. For what values of x is f of x equal to 0? We just talked about that. Y equals 0 is the same as f of x is equal to 0, which is the same as being on the x-axis, which is the same as x-intercepts. So these are all asking the same thing. F of x equals 0, y equals 0, being on the x-axis, looking for x-intercepts, all of those things mean the same. So we come along here and we see that we have 0, 4, and 6. Our x-intercepts are 0, 4, and 6. And they're asking for values of x, so I would leave it like this, not as points. All right, next, f of x less than 0, f of x less than 0. So this time we want to know where our function values or our y values are less than 0. And we remember what we just talked about. That's the same as saying, where is the graph below the x-axis? So let's find that part of the graph first, and then we'll decide the values of x for the answer. So we come up to the picture, we figure out where we're below the x-axis. I'm going to do that in orange here. So we find where we're below the x-axis. We did that. That's the part of the graph that we're looking for. And now our answer needs to be the values of x that give us that part of the graph. Values of x. So we can do this two ways. We could do it as an inequality or as an interval. Looking at the graph, we go from left to right. Here x is 0, here x is 4. So we want all of the values of x from 0 to 4. So we could say x goes from 0 to 4, like this is an inequality. And since we're not including 0 here, we're not actually hitting the x-intercepts, we're not going to include 0 and 4 in our answer either. Most of the time, if the question's not included, then the answer's not included either, about 99% of the time. We could also write this as an interval. Remember, for intervals, we go from left to right. We start at 0, we stop at 4. And since we're not included, we're going to use round brackets. Okay, if you're not as comfortable with interval notation, there's another review video in the modules that you can take a look at for those. Okay, we got A through F done. Moving along to G and H. Domain we talked about a little bit. Remember, domain is all of the allowed x values. All of the allowed x values, and we talked about how to look at that in terms of a function. Now we're looking at it in terms of a graph. So what that means is we're looking for all of the x values where the graph exists. So all of the x values where the graph exists. So we're going to go from left to right, and we're going to list all of the x values where the graph exists. So there's no picture out here where I've written in purple. There's no graph out here. It starts at -4. It goes all the way through to +6. And then there's no picture again out here. So we have all of the x values from -4 to +6. So -4 to positive 6. And this time I am going to include them because we actually touch those. So you can see I have a point here at -4, and I have a point here at positive 6. If it was like an asymptote or an open dot, then we wouldn't include them. I could also write this as an interval. I would go from -4 to positive 6 with square brackets because we're included this time. Okay, so we're looking for x values, and we're looking for every place that the function exists. Now, we didn't talk about range before because in terms of looking at the function, it's somewhat difficult to look at range. It's much easier to find range by looking at the graph. So the range is similar to the domain, but we're looking for all the y values now. So it's a little bit hard to look at a function and imagine all of the y values that you would get out of it, but it's much easier to look at the graph and see all of the y values that you get. Similarly to domain, domain goes from left to right because we're looking at the x values. For range, we're going to go from the bottom of the graph to the top. So we're looking at y values now, right? Y values go up and down. So we're going to start at the bottom and work our way to the top. So again, we're looking for where the graph exists. Down here, we've got nothing. The graph starts at -2, that's our lowest y value, goes all the way through to positive 3, that's our highest y value. So this is what I'm looking at, -2 and positive 3, and then there's no graph above that. So our range goes from -2 to positive 3. -2 to positive 3, or as an interval, -2 to positive 3. So for domain, we're looking for x values, we go left to right, and for range, we're looking at y values, we go from the bottom to the top, and you're looking for where there's a picture, where the graph exists. Okay, moving along to the next one, we're looking for x-intercepts. We actually already did this. Remember, we looked at it over here, part E. X-intercepts are the same as where f of x is equal to 0, so we had 0, 4, and 6. So you could write that as x equals 0, 4, 6, or you could write it as the points. And I'm not too picky on that. Whoops, I wrote that backwards, didn't I? I'm not too picky on listing them versus points. You're just going to have to use context clues to figure out what MyMathLab wants. Both of these answers would be considered acceptable. The y-intercept, we look along the y-axis. So along the y-axis, we just have one y-intercept, and that's at 0, 0. And we see that 0, 0 occurs in the x-intercepts and the y-intercepts. If you have 0, 0 on the graph, it's going to be for both, because it's an x-intercept and a y-intercept at the same time. Next, part K, how often does the line y equal 1 intersect the graph? You should remember this from the days of yore when you did lines in other classes, that this is a horizontal line. Oh, that should say horizontal there. This is a horizontal line at -1. So if we draw a horizontal line at -1, I'm going to dash it in here. How often does the line intersect the graph? We don't know exactly where it's going to be, but we can see that it's going to intersect 2 times. So we could say twice or 2 times. How often does the line x equal 1 intersect the graph? This is a vertical line at 1. So x equals 1 is right here. Vertical line looks like this. And that's going to intersect 1 time. And remember, if it's a function, it can't intersect more than once. So if you're talking about functions, it should be 1 or none for any vertical line.